Is it recording? Cool, we're live. Okay, good. I can actually get this. So today's lesson, okay, it is 3:26. Viernes. Marzo viernes 20 y 21. There we go. Our objective is logarithms. Logarithms. And what logarithms are, they really are exponents. Logarithms are exponents. And what they allow us to do is they allow us to solve for exponents. Calculators really help quite a bit on logarithms. And if you have a calculator, your Desmos, your phone will do logarithms. It will. But it really is helpful to have a decent calculator. So let me go back to the example I had. I had 10 to the x equals, I think it was like 4, I'll just make up a number. Let's say it's 578, okay? Here's an example, okay? So I know that x has got to be bigger than 2 because 10 squared is 100, but it can't be 3 because 10 to the third is 1,000, right? So it's about 2.5 something maybe. I'm kind of guessing, right? But guess and check is really the wrong way to do it because it's just a pain. But what we want to do is change it from this form. This is exponential form. I'm going to highlight that. This is my exponential form. So I'm going to change this expression from exponential form into log form. This is my log form. How does it work? All right. So if I take my example, 10 is my base. 10 is my base. Okay, that's my base. That's my exponent, and that's the answer. Okay, one more time. That's my base. 10 is my base. That's my exponent, and that's my answer. So let's convert this into log form. So it says go and whereas log, L-O-G, log, and it's a function in my calculator, log of my base, which is a subscript 10, of the answer, which is my 578, will actually give us the answer of the exponent, okay? So in my calculator, I have a log button, okay? So my calculator go, and I open up my calculator, and I got a log button. It's right here, okay? So the logarithm is this same log here. So I'm going to go ahead and push log. Now, one of the things you don't see in this button is you don't see the 10. You don't see the 10 at all, right? See this 10 right here? And the reason you don't see the 10 is because this is called common log, base 10. So this is called common log. And if you don't see the 10, it's invisible. So base 10 is our common log because it's obvious. Base 10, we count, we live in base 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? We don't live in base 8. We don't live in base 6. We live in base 10. So when they talk about common log, if there's no number here, it's always 10, okay? It's invisible, okay? So then if I take my calculator and I want to do the log of 578, I get an answer. 2.7619, blah, 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 blah. So that's got to be the answer. So then 10 to that power, okay, 10 to that 2.78, blah, 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 should equal 578, right? And it does. So logarithms allow us to solve for exponents, okay? Logarithms allowed us to find the exponent, okay? Thumbs up on that? So then let's take a look at example 1. So in example 1, we just want to rewrite it, okay? We're going to change it from this form to this form. So the base is 2. It's base 2, okay? So we're going to go log base 2 of my answer of 8 equals my 3. So I went log of my base, log base 2 of 8 equals 3. Okay, and that's a subscript number, okay? And if you had a fancy calculator, which I do, Not everybody has this button, but it's kind of nice if I have log base 2 of 8. It'll do it for me. 3. Kind of cool, huh? B. All right, we're going to change it from exponential form. That's my base. That's my base, base 10. I'm going to rewrite here, base 10. So I'm going to go log base 10 of 100 equals my exponent, or x. Now, since it's base 10, that's fine. That's fine. But we could just write as log of 100. You don't need the 10. If it's base 10, it's invisible. You don't need the 10 if it's base 10, okay? It's implied. And I know you guys agree the answer's got to be 2? 10 to the 2 power, you guys agree it's 2? Well, check it out. It's got to be. So if I go log of 100, guess what I get? 2. It's got to be 2. All right, now C. Let's go log. My base is base E, right? My log is base E of 2 equals x. Yesterday, we learned that this was a special number. So when I see this number, we called it the natural number. So when we do log base E, we do what we call the natural log. And the reason I say that is we're going to go ln. We're going to rewrite as ln because that's in our calculator. There's an ln button. See, there's a log, and there's an ln log, okay? So we're going to go ln of 2 equals x. So when you see ln, you know it's base E. I mean, otherwise you could go, okay, so ln of 2 is faster than, because you can do it this way, log base E of 2, and you get the same answer, but what a pain, right? So if you see ln, it means log base E. We will not write as log base E, okay? How am I doing? We're doing okay? So we get 2 special logs. Common log is base 10, it's invisible. Log base E, we call a natural log. In any other log base, we just put the base in, okay? This is base 10, it's invisible. This is base E, we call it natural log. Any other base, we just put the base down, okay? All right. Next part. Let's go ahead and rewrite this into exponential form, okay? So we're going to take it from this form to this form. So we're going to go backwards. We're going to take it from a log form to an exponential, okay? So we're going to write them like this. So 4 is my base. 4 is my base. I'm going to go 4 to the x power equals 16. So I rewrote it in exponential form. I just went 4, that's my base, to the x power equals 16. And x should equal 2. You guys agree with that? X is 2. Has to be because of 4 squared. And in fact, on my fancy calculator, which I have fancy calculator, I could do this. We can actually do log base 4. I can go log base 4 of 16. I should probably get an answer of 2. Kind of like I thought, right? Okay, B. What is the invisible base? What's the invisible base? What's the invisible base? 10. Nice job, Francisco. Totally right. So I'm going to set it equal to x because I want to rewrite it. So I'm going to go 10, because that's my base, to the x equals 1,000. And x obviously is 3, because 10 times 10 times 10. You okay with that? In fact, I could even do it on my calculator if I really wanted to. I can go, what's log of 1,000? Log of 1,000 is 3. I knew that already, though. Okay, now, C. What's the invisible base? What's the invisible base? It's that number right there, isn't it? Isn't it E? So the invisible base is E. So I'm going to rewrite it. That's my base. E to the 4 power equals x. Good job, Francisco. And that's it. Okay, now 3. Now, since you guys don't have a fancy calculator, we're going to have to solve this using our brain. Well, we can do that. I'm going to set it equal to x because I want to change this into 3 to the x equals 81. Okay, so 3 to what power equals 81? 3 to what power equals 81? 3 to what power equals 81? 4. 3 times 3 is 9, times 3 is 27, times 3 is 81. X is 4. But that's kind of a pain. Don't you wish we could do that on a calculator? But we can if you have a base, if you have a logarithm in your calculator and you go math. I'm going to go to logarithm. So I can go log. This is easier than log base 3 of 81. And Vanessa said 4, and I agree. So the calculator can do it if you have a nice calculator, right? You got to have a good calculator to do this. Okay? So this is the same as 5 to the x equals 1. All right? Anybody know what x should be? Well, let's see what the calculator says. So let's see, math. All right, I'm just going to check it out. Log base 5 of 1. Let's see what it says. 0. 0. Well, actually makes sense because any number to the 0 power is always 1, isn't it? So x has to equal 0. Anything to the 0 power is always 1. All right, C. Well, you can't do it without a calculator. You have to have a calculator. So check your phone. Everybody have their phone? Go to your calculator on your phone. It has it. It has regular common base. If you go to your calculator, turn it sideways. Come on, turn it sideways for me. Oh, come on. Come on. There we go. Oh, stop that. You actually have a log button in your calculator. See it? You got log base 10. So I could go 431 and push this log base 10, and there it is. Okay, so your phone can do this. I know it's base 10. I like the calculator better than my phone just because I'm old and most of my life has not been with a phone. So, you know, pretty good on a calculator. Same answer, right? Is my calculator or is my phone? So your phone can do it or your calculator. Okay, so basically it's like 10 to the 2.63 blah, blah, blah should equal 431. Okay, how am I doing? Okay, thumbs up. Okay, now there's some rules that go along with logarithms that may not seem obvious, but let's take a look at the rules, okay? So this rule, if these two numbers are the same, if the base and the answer are the same, they cancel each out, tear it out in a sense, it just equals 1. As an example, if I have, let's say log base 5 of 5, that answer is 1 because it means 5 to what power equals 5? Well, it's got to be 1. That's why it works. So if these two numbers are the same, the answer is just 1, okay? Same thing here. If these two numbers are the same, the base and this, instead of 1, it just equals x. So if you had example here and you had log base 5 of 5 to the x, it'd be like 5 to some power here. Let's see why it goes 5 to the x. It's got to cancel each other out. It's got to be just plain old x. Okay, and this one we just talked about it. So you have any number to the 0 power equals 1. So log of anything, in fact, check it out. If I go log of 1, it should equal 0. Okay, so log of 1 is always going to be 0. Now, the one thing you can't do is log of 0. You can't do log of 0. It won't work. Because you're looking for an exponent, okay? You're saying b to some power equals 0, okay? This is like our half of the half of the half. Remember how we did this? If I'm going to walk halfway to the wall, will I ever get to 0? Remember how we did half, go another half? It will never equal 0. In fact, if I tried it on my calculator and I went log of 0, guess what I'm going to get? Error, no good. So you can't take log of 0. In fact, you can't do log of any negative either. You can't do the log of any negative number, so it's always got to be greater than 0, okay? So you can't do a negative either. Negative, and can't do that either, okay? And this is very similar to the rule up here, except it's written the other way. if these are the same two numbers, log, if you got an exponent b to the log of b, they cancel each other out and it just equals x. So an example of that might be, oh, like that one right there. There's my example right there. So if you had 5 to the log base 5 of x, because these are the same, they in a sense cancel each other out. You just left with x, because it's like 5 to the x equals 5 to the x. Okay? So these rules, you won't see them very often, but they're rules to know. All right, so let's look at example 1. Or let's look at A. So when I do A, there's an invisible number here. What's my invisible base? It says log, it's invisible. What's my invisible base? 10, right? So it really is this example here. These two numbers are the same, right? The base and the log base are the same, so the instants cancel each other out. And all you're left with is just 3x. B, these are the same, the 3 and the 3, 3 and 3. So they cancel each other using this rule up here. They cancel each other out. You're just left with 2x. And C really is this rule up here. You can't take the log of a negative number. It won't work. This is undefined. In fact, you can try it. I mean, I have a natural log button on my calculator, I really do. My ln's right here, so if I go ln, I go natural log of -2, and I get an error, right? Non-real. So you can't take the logs of negative numbers, okay? All right, last thing to do. So logarithms are really inverses of exponential functions. What we did yesterday is we graphed exponentials. And one of the things we did yesterday is we started plugging in numbers. Like I plugged in -2. So I want to just graph this. So I plug in -2. 2 to the -2 is 1/4. Then we plugged in -1, and 2 to the -1 turned out to be 1/2. Plugged in 0. 2 to the 0 is 1. And you can check these on your calculator if you want to. You can just plug them in. But I'm definitely, I plug in 1, 2 to the 1 power is 2. If I plug in 2, 2 to the 2 power 2 squared is 4. And finally I'll plug in 3. 3 to the third power is 2 times 2 times 2. 2 to the third power is 2 times 2 times 2, which is 8, okay? Okay, let me graph these. So I'll graph these in blue. So if I'm going to graph this, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2, 3, 1, 2. Okay. All right. So if I graph this, and we graphed these yesterday. These are my exponential. -2, 1/4 is about there. -1, 1/2 is about there. 0, 1, 1, 2, 2, 4, 1, 2, 3, 4, 3, 8. Okay. So this looks like what we had yesterday, right? Looks just like we graphed yesterday. We know it never touches the x-axis, right? And that's an exponential function. We also talked about how it has a horizontal asymptote because it never ever touches that line, right? So we did that yesterday, right? Thumbs up. Today, though, we want to do its inverse. So to do its inverse, we want to graph y equals log base 2 of x. Okay, that's its inverse. So to do the inverse, let's switch the points, okay? Inverse. Let's switch the points. Inverse. Let's switch the points. We're going to go 1/4, -2. We're going to go 1/2, -1. We're going to go 1, 0. We're going to write it as 2, 1. We're going to switch it 4, 2, and we're going to switch it and make it 8, 3. And then we've got my inverse points. Let's graph it. See what it looks like, okay? All right, I'm going to have to add to my graph here. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to graph 1/4 1/4 -2, 1/2 -1, 1 0, 2 1 2 1, 1 2 3 4 2, 1 2 3 4 5 6 7 8 3, and it looks like this. That's my log graph, and it has an asymptote also, but it has a vertical asymptote because it never touches this line. So the domain is super important. The domain of the log graph is x is greater than 0, and that is why that won't work and that won't work, because it doesn't exist, right? Okay, that's what I have for today. I asked my last class whether they wanted me to work on their homework with them or if they wanted to work on egg drop. They wanted me to work on the homework with them. Come on, stop. Stop. Stop.